Hello, this is Patrick with Super Tutor, and I'm going to work on ACT Science with you. So the first thing is let's just quickly take an overview of what the passage looks like. So this is one of the passages in the section. You can see, and this is a typical format, they have a intro, and then they usually have different sections, and basically they have this section here, which is table 1, and then they also have another section here, which they call figure 1. So what I'm going to do first is I'm going to look over the questions really quickly to see how many of the questions are dealing with table 1, how many are dealing with figure 1, and how many of them are dealing with both of them. And then that will give me some information about how I might want to attack the problems. And then you can see here we have 1, 2, 3, 4, 5 questions for the passage. Okay, so that's what I'm going to do first, is look at specifically what are they focusing on. So here I can see the first question is on table 1. So I'm going to put a T for the table, because they're basically just a table and a figure. The next question is table 1 and figure 1. So I'm going to write B for both. Another one is table 1 and figure 1, so that's B for both. And this one is table 1, and so T for table. And then lastly, table 1. All right, so what I know is I have 3 questions that deal specifically with table 1, and I have 2 questions that deal with both of them. So in that case, I would probably spend more time with table 1 and answer all of the table 1 questions. And then after I've answered all the table 1 questions, then if they did have questions about figure 1, I would go on to figure 1 and answer all the figure 1 questions, but they don't have any questions that are focused solely on figure 1. And then I would do questions that deal with both figure 1 and figure 2. Okay, so when the introduction is brief, and so here I can see that basically we have a introduction, and then here they have a discussion of table 1. So the introduction is so short that I would read over the whole thing. If it was really long, I might not read it. I might go directly to the questions and then read only if I have to. But often you can actually figure out what you need to know just by looking at the data table or the data chart. But like I said, this one's so short, I might as well just read it. Okay, so I'm going to read and I'm going to highlight or underline as I go. So ferric oxide, I don't get intimidated by fancy terms. It doesn't matter if you know what the heck this is. Just know that this is stuff. Is more commonly known as rust. Great. So anytime I see this term, I'm just going to call it rust. This, meaning rust, is produced in reaction with iron, a common metal, and water, H2O. So here, and this arrow is showing that you have something results. So some iron plus some water results in some rust and some hydrogen. So far, that's all I really need to know. So basically, some iron and some water results in some rust and some hydrogen. Okay. Now I'm going to go right to the questions, even though I haven't read anything else. So it says, based on table 1, if the amount of rust produced on day 9 had been measured for the salt solution, it would most likely have been what? So the question itself is telling me exactly where I want to look. So I want to look at table 1. I want to look for day 9. I want to look for the salt solution, and I want to see how much rust would have been produced on that day. So I'm going to go to table 1, find day 9, find salt solution, find rust produced, and then answer this question. Okay, so here's table 1. Ding, ding, ding. Here's salt solution. And I can see they don't have a day 9. They do have a day 2, day 4, day 6, day 8. And so I'm basically looking what happens to the amount of rust that is produced over time. Well, I can see there's a very clear pattern here that the amount of rust increases every day. So the longer the days are, or excuse me, the longer period of time, the more rust is produced. And so I can definitely deduce that on day 9, there would be more than 1.84. And it would be a little bit more, not a great amount more. And this is a very common type of question, which is basically make a prediction based on the other data of what this amount would result in. So I know it's going to be more than 1.84, and there is only one choice that is more than 1.84. All the other ones are less than 1.84, so I choose J and I move on. Now I know that question 7 and 8 both deal with both table 1 and figure 1, so I'm not going to answer those right now. I'm going to answer the other table 1 question because I have that fresh in my mind. So here it says, according to table 1, what was the amount of rust produced by the sugar solution from the time the amount was measured on day 6 until the time the amount was measured on day 8. So again, it's telling me, look at table 1, look for the amount of iron in the sugar solution from the measurement on day 6 until the measurement on day 8. So I'm going to go to table 1, find sugar solution. So let me erase some of this stuff. Okay. So now I am back to table 1. This time I'm looking at sugar solution, and I think they asked day 6 until day 8. So here's my day 6, here's my day 8. So the two key figures are these. And so how much was produced, how much rust was produced from day 6 until day 8? Well, day 6 it was 0.11. Day 8, it was 0.19. That's a simple subtraction problem. And even if you think you can do it in your head, you might want to just write it out to be absolutely sure that you get it right. Take the extra second and a half to write it out. And so I know it was 0.08. I don't need to know what the stuff was. I don't need to know how it was produced. All I need to know is that it was 0.08, and that's the answer. And then I can just move on. Okay, and let's see. Oh, this one also has to do with table 1. So I'm going to answer this table 1 question, and then I'll deal with both. Okay, so now it says, based on table 1, which graph best shows how the amount of rust produced by a sugar solution changes over time? So a very, very typical kind of passage, very typical kind of question. So basically, what is changing over time? The amount of rust is changing over time. And how do different things like a sugar solution or a salt solution influence how much rust is produced? And so I have 4 choices. So I have this one, which is an increase in rust. This one's a decrease, this one's a decrease, and this one's an increase. And I definitely remember that the rust increased over time. So it's definitely going to be either the first one or the third one. So now I basically want to see, well, how are these two different? How is this graph different from this graph? Well, I can see that in F over here, this first one, that it's a pretty steady growth over time. But in this one, it starts off as a steady growth, but then it starts to taper off and it looks like it's going to plateau. So for me, I would probably look at where is the place where the numbers seem to be the most different in those two charts. So here in day 4, it looks like the rust is about 0.05. And here on day 4, it looks like the rust is about double that, or 0.10. And so that might actually give me enough information to kind of figure out which one is the better choice. So I'm going to look for day 4 in table 1 in sugar solution and see if it's closer to 0.05 or 0.10. Okay. Sugar solution, day 4, 0.05 on the nose. So that's going to be the right choice. So I would choose F. Okay. Now I have 2 questions to go. I've already spent a good amount of time on table 1. And I haven't looked at figure 1 at all yet. So now I want to look at the first question, which deals with both of them. Okay, so the first question says, in the experiments shown in table 1 and figure 1, by measuring the rate at which rust was formed every day, the experimenters could also measure the rate at which what? So one of the things I mentioned in my packet is you want to identify what is the core question. This one is kind of wordy enough that we might need to do a little bit of focusing for what's the core question. I think in the other questions were so straightforward, like how much would have been produced on day 9 in the salt solution. That was so straightforward. We didn't need to sort of distill a lot of words and get to the core. But here I think we kind of do. So here they're saying essentially, if you measure the rate that rust was formed, you could also measure the rate at which, and then they give you your choices. Water was produced, hydrogen was produced, iron was produced, or FeO, which looks like some kind of iron oxide. But you don't even need to know what the terms are. You can just call them H2O, H2, Fe, FeO, all that's good. So basically they're saying if we're going to measure the rate at which rust is formed, we could also measure the rate which water was formed, hydrogen formed, Fe formed, or FeO formed. This is, there is nothing in table 1 that directly answers that question. So then I would go on to figure 1. In figure 1, it does talk about the amount of rust that's produced over time. So another thing that you really want to do is make sure that you are paying close attention to your terms. And then they're giving us different pHs, or how acidic the water is. So that's not really telling us anything either. So I'm guessing that the information to answer this question is going to either be in the short intro that we read, or it's going to be in this little paragraph or this little paragraph. Now, if you remembered closely from the intro, you might actually remember that the intro mentioned that 2 things are produced. So when you have some iron and some water, you get some rust, and you also get some H2. And so it's reasonable, if you're measuring how much of this product is being generated, you could also measure how much of this product, or the rate at which that other product is being made, and that's going to be the answer: how much hydrogen, or H2, was produced. There's no place where FeO is mentioned. The only place the only place where they mention Fe is here and here, and they don't say anything about it being produced. They talk about that being essentially an ingredient, and so that's the only one that makes sense. If I didn't know that it was there, then I would have to skim over this paragraph and this paragraph to see if I could find the information. Okay, I am really marking the heck of this thing up. So I'm going to do some erasing so that things are a little cleaner. Okay, so now I have one more question that deals with both. All right, and you may have noticed that so far I haven't read that, and I haven't read this. So you should only read what you absolutely have to read. And so far, it hasn't been necessary for me to read either of those. Okay, maybe in order to answer question 8 confidently, I'm going to have to. We'll see. So question 8 says, consider the amount of rust produced by the salt solution on day 2. Okay, so they're telling me rust, salt solution, day 2. Then it says, based on table 1 and figure 1, the water buffered. So far, we haven't really seen anything about buffering water, and you really don't even need to know what buffered means. It just means some kind of water, or something done to water. So it says the water buffered to a pH of 10. Obviously, it's nice if you know that pH is measuring acidity, so that would make sense. But essentially, they're just, even if you didn't know that, they're attaching this pH 10 to some kinds of water. And that's fine. You don't need to know exactly what that means in order to answer the question. So basically, based on table 1, figure 1, the water buffered to a pH of 10 produced approximately the same amount of rust on which of the following days? Okay, so this is a good example of, this is almost like a word problem with several parts. So part 1 is right here. Consider the amount of rust, and it's the first sentence. Consider the amount of rust produced by the salt solution on day 2. So let's just figure out what that is, and then be done with it. Okay, so rust, day 2, salt solution. Okay, rust, day 2, salt solution. 0.56. That's it. 0.56. That's what we're dealing with. So here, we're dealing with 0.56 grams. So that's basically done. So now they're saying, the question is, based on Table 1 and Figure 1, the water with a pH of 10.0 produced approximately the same amount, meaning it produced about 0.56 grams of rust on which day? All right, so now I need, and obviously this pH stuff was not included in Table 1, so it's got to be included in Table 2 and it's not Table 2, it's Figure 1. And here they give in my key, they're telling you that pH of 10 is represented by this solid line. And I know that they're saying on which day was 0.56 grams of rust produced. So 0.56 is a little bit more than 0.50. And so it looks like the only days where 0.56 could have been produced is day 8, day 9, or day 10. So let's look at the choices. Well, the choices, the only one that's there is day 10. That's the only one that fits the bill. So we don't have to look any further to see, is it day 8, day 9, or day 10? The only one that makes sense is day 10. And believe it or not, we are done with that passage. Now, obviously, it took a long time because I was explaining everything in very, very fine detail. But one of the things that you might notice is we didn't read this, we didn't read this, and all we had to do with Figure 1 was pay attention to one part. The other 3 parts didn't factor in at all. Didn't matter at all. So we didn't have to worry about any of that stuff. That was it. That was enough for us to answer all those questions. So there you have it.